Welcome to Decoding AI, the podcast where we unravel complex research papers and make them understandable for everyone. I'm your host, Alex, and today we're tackling a fascinating paper titled Attention is All You Need. It's a title that sounds almost arrogant, right? But trust me, it revolutionized the field of machine translation.
Hey Alex, I'm Ben. Glad to be here. Yeah, attention is all you need does sound pretty bold, but it's justified. Before this paper, sequence transduction, like translating languages, was dominated by recurrent neural networks, or NN. They had this inherent sequential nature, which made parallelization a nightmare, slowing everything down.
So, RNEs were the old guard. What problem exactly did they solve for us?
RNNs work by processing information sequentially, like reading a sentence word by word. They remember the previous words to understand the context of the current word. That's the recurrent part. This worked pretty well, but it limited how quickly you could process large amounts of text. It's like trying to build a house brick by brick, in order, instead of assembling pre-made walls.
Okay, I'm picturing it. Slow bricklaying versus a prefab house. So where does attention come into play?
That's where the transformer architecture comes in. The core idea is to use attention mechanisms to directly relate different parts of the input and output sequences, regardless of their distance. It's like the model can attend to relevant parts of the input sentence when generating the output, without needing to go through each word in order.
So, instead of reading a sentence word by word, the transformer can look at the whole sentence at once and figure out which parts are most important to the translation. Is that accurate?
Exactly. It's a parallel process. Think of it like a team of translators simultaneously analyzing the input sentence, each focusing on different aspects, and then combining their insights to produce the final translation.
That sounds computationally intensive. How does it actually work? I noticed mentions of keys, queries, and values in the paper.
Okay, simplified version. Imagine you're searching for a specific file on your computer. The query is your search term. The keys are like the keywords associated with each file, and the values are the actual file contents. The attention mechanism calculates a score based on how well the query matches each key, effectively determining which files are most relevant to your search. Then it combines the values, file contents, of the most relevant files to give you the result. It does this by weighting the values by a score.
So the model is comparing the query to all the keys, and the output is weighted by how relevant the query is to those keys. Sounds like a database search, but on steroids.
Precisely. And the paper introduced a multi-head attention mechanism, which means the model performs this attention process multiple times in parallel, each with different learned linear projections for the queries, keys, and values. It's like having multiple search queries at the same time.
So multiple angles of attack to better contextualize the translation, and then combine all the insights.
Correct. This allows the model to capture more complex relationships between words.
The results of this model seemed impressive. It surpassed previous models, even ensembles, with significantly less training time. Why did it have such an impact?
Because it was faster and more accurate. The ability to parallelize the computation drastically reduced training time. It not only achieved state-of-the-art results on English to German and English to French translation, but did so with a fraction of the computational resources. It truly changed the game.
This sounds like a purely technical advancement. Are there any broader ethical or societal implications to consider?
Absolutely. Better machine translation can facilitate communication and understanding across cultures, breaking down language barriers. However, it also raises concerns about job displacement for human translators. Plus, the potential for misuse in spreading misinformation or creating deepfakes is there. With the model understanding dependencies so well, and not just translating word for word, This is a powerful tool.
That's a good point. Every technological advance brings its own set of challenges. What are some limitations or future research directions stemming from this paper?
While the transformer excels at capturing long-range dependencies, it can be computationally expensive for very long sequences. So, research is ongoing to improve its efficiency for processing extremely large documents or video. Also, applying the transformer to other tasks beyond sequence transduction, such as image recognition or reinforcement learning, is a hot area of research. It is applied today in models like GPT.
Okay, so to summarize, attention is all you need. Introduce the transformer architecture, which uses attention mechanisms to achieve state-of-the-art results in machine translation with significantly less training time than previous recurrent models. It allows for parallelization and more accurate capture of long-range dependencies, but also raises ethical considerations and has limitations for very long sequences. Thanks, Ben. That was a great breakdown.
My pleasure, Alex.
And thank you for tuning in to Decoding AI. Join us next time as we tackle another fascinating research paper and make it accessible for everyone.